All right, we're good to go. So, welcome back, and if you haven't again, go hit the QR code. I'll put that back up later if we still need it. I'm going to go back to last session, Module 2, and I would like to, before we look at the code and the two exercises, and I'll go over those in detail, then what I'd like to do first is we stopped with while loops. So if you remember, we did Boolean expressions, we did if statements, and then we talked about loops. And one of the loops we did was a while loop, where we said while some Boolean condition is true, repeat these steps over and over again, and then when it's no longer true, we were done with that code. So here, this started out numbers 5, while number was less than 100. It just printed out the number and kept adding 5 to it. As long as it was less than 100, it kept printing out. So it printed out 95 was the last number, because when I got it to 100, 100 is no longer less than 100, and it fell out of the loop and went from there. And so we did a sample questions, but I want to talk about this one. And this, I made a little video for it. So if you watched it, great. If not, no big deal. This is another type of loop. And hey, welcome. I got some slides right there. Remind me, I'll put the QR code back up during the break here. We've got our while loop, if you remember. And again, this is on the last unit, the module 2 stuff that we did. But the while loop had an initialization like number equals 5, a conditional while number was less than 100, and then inside the body of the loop it said, number plus equals 5 or whatever, it kept changing it. So there were those 3 parts here, right? There were the 3, to go back here, it was the initialization of number, my Boolean condition, my check, and then something in here that was going to change number so it was eventually false. Those 3 things are needed to have a successful loop. With a for loop, you get the same idea, but you get it all in one line. So you have that initialization, the Boolean expression, and my update, my change to it. So it looks kind of like this. So in this case, like I had number was equal to something or other. This one is my initialization, x equals 1. While x is less than or equal to 5, x plus plus, that's my update. So what happens is when I run this code, it's going to print out 1, 2, 3, 4, 5. It starts out as 1. It prints out 1. And then it comes back up here and says add 1, it's 2. Is 2 less than 5? Yep. Print out 2. 3. Is 3 less than 5? Print out 3. 4. Is 4 less or equal to 5? Print out 4. 5. Is 5 less or equal to 5? Yes. Print out 5. 6. 6 is no longer less than or equal to 5. And now I'm done. So it does the same thing. It's just another way of repeating series of code over and over again. A while loop and a for loop are equivalent. You could use one or the other interchangeably. It just depends on what A, your preference is, and B, we usually say, well, if I know exactly how many times I'm going to do a loop, maybe a for loop is better because it says here's where I'm starting, here's where I'm finishing. But if you're like, I'm going to keep looping until I run out of something, or I'm going to keep looping, like on the countdown, I'm going to keep looping until I hit to 0, that might be a good use for a while loop. But with the countdown, you could also say, oh, I'm going to start at this number and I'm going to end at 0 and do a minus minus. So there's really, it just depends on what you think is best for your situation when you're writing that code. So here, these loops real quick, what do these display? So I go from 0 while it's less than 10, x plus plus, right? So it's going to add by 1 every time. So it's going to print out 0, and then it's going to print out 1, and it's going to print out 2. What's the last number that would print out? 9. So it prints out, whoop, I thought I had I guess I don't have the answers on here. It prints out 0 through 9. What about this, though? Here I've got 1, y less than 100, y equals y times 2. So it's going to print out 1, then 2, then 4, 8, 16, 32, 64, and then we're done. Because 128 would be greater than 100, so it's no longer going to loop. Likewise, we can do, let's take that idea with strings. Remember we did substring, which got as part of a word, like the first letter. We did this with the Pig Latin project. What happens here if I print, I have a loop that says I less than word dot length, so it's going to go from 0 to the length of the word, and I'm going to print 0, comma I plus 1. So it's going to be 0, 1, then 0, comma 2, 0, comma 3, 0, comma 4, 0, comma 5. And that does what? That says start at the beginning and go up to that number, right? So think about what that's going to do. And then here, I've got word.length, but I'm going to print word.substring I comma I plus 1. So it's going to be 0, 1, then 1, 2, then 2, 3, then 3, 4. And these print two different things. I'm going to run this print letters program, which is these two loops together, to show you what this does. So print letters, here is the same thing we just saw. So I've got a word, I put quadrilateral, just 'cause it's a great word.
Yeah.
It's got a lot of letters, and it's cool. It's fun to say, quadrilateral. Word.length, and then here I got 0, comma I plus 1, so it's going to go 0, 1, 0, 2, 0, 3, 0, 4. Think about what this is going to print, and then I just print this out to separate it. And then this is going to do the same thing, but it's going to do I comma I plus 1. So look what happens when I run this, and I run it down here, it does this. So the first, it prints out Q, QU, QUA, QUA, then 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6, up to including. But then this one prints out 0, 1 is the Q, 1, 2 is just the U, 2, 3 is just the A, right? 3, 4, start at 3, up to but not including 4. All of those are going to print out one letter, and it's going to be one letter at a time, starting at that letter all the way down, so it prints out the word vertically. So just different things that it could do. A lot of times you'll see on the test, some string manipulation questions. What does this output? What does this print? Just knowing what those parameters do when you call the substring method is very helpful as well. All right, so here, so that was it. Another thing that you can do is you can use what's called nested loops. And this is something where you could do, if I wanted to print out like a set of blocks, and on the first row I print 1, this is the brackets, open and close brackets. On the first row I print 1 set, on the second row I print 2, third I print 3, 4 I print 4, 5 I print 5. So what we could do here is we could do what's called the nested loop, a loop inside of a loop. So this tells me how many rows I want. I want rows from 1 to 5, right? Because that's what we had, 1, 2, 3, 4, 5 rows. And so now I want to make blocks on each row. So this is the number of rows I want, and I'm going to print out a certain amount on each row. But how do I make the blocks on each row? Well, I'm going to need another loop. So I'm going to start at 1, and I'm going to go while j is less than I. What's I? I is this number. So in the first row, I'm going to go from 1 to 1. On the second row, I'm going to go from 1 to 2. On the third row, I'm going to go from 1 to 3. And what happens is, every time I jump in here, this loop starts over again, and it prints out all my blocks, and then when I go to the next row, this row prints all over again. So we combine them, it looks like this. So it's a loop inside of a loop. And like I said, when this is 1, this is going to go from 1 to 1 and print out 1 block. Now this is 2, and this is going to go from 1 to 2. It resets and it prints out 2 blocks. When this is 3, this is going to go from 1 to 3. 4, 1 to 4, 5, 1 to 5. And so I've got this, and this code is on eCampus. You can download it as well if you want to look at that. Here's Triangle Demo. Oops. Basically what I have here, I said n is equal to 10, and so I did each row and blocks on each row. So when I run this, and there we go. So you can have loops inside of a loop. So how does that work? The outer loop and then the inner loop. It's kind of like a digital clock, right? When you have 1 o'clock and then it goes from 0 to 59, and then it goes 2 o'clock, and what happens in minutes? 0 to 59 again. 3 o'clock, 0 to 59. 4, same idea, right? So it's a counter inside of a counter, but every time the outer loop resets or increments by 1, the inner loop resets and runs the whole thing all over again. So that's what nested loops are. We'll see some questions when we get to that, especially as we do some sample tests. You're just tracing through code. But if you see a loop inside of a loop, that's the kind of the idea. Make sure the outer loop and the inner loop resets. And that was really it for that section. We did this one. It was the while loop that we had here, and then we did our code. So I want to talk about these two programs that we did: the countdown and the magic 8-ball that we had. So I'm going to look at both of those. Let's start with the magic 8-ball one. A lot of people have some great, and as always, I usually put a comment on your eCampus. I don't know if eCampus notifies you of a comment. My kids swear it doesn't. But there's some setting on there, and I tried to tell her to set it.
You have to look, yeah.
You have to look at the sidebar, it doesn't just.
Yeah, so, so let me pull that up here. Oh, it logged me out, hold on. I had it all set up. Is it here? No, that's, oh, here we go, Magic 8 Ball. So, so a lot of people had some good programs here, but some of the things that I saw, remember, we started with this, I gave you this, how to do a random number from 1 to 8. So then, what does the Magic 8 Ball do? You want 1 of 8 responses. So, you needed a bunch of if statements. I did it this way by saying if, random number, and again, double equals. I just want to see, does it equal 1, or does it equal 2, does it equal 3, does it equal 4? Do it that way, that's one way of doing it. A number of you use the greater than or less than signs, which were fine, but you got to be careful. Remember on earthquake one, you only want one of those options picked. So how you organize that was important. Like if you had it was, okay, if it's greater than 1, print out yes, greater than 2, print out this, greater than 3, print out this. Well, anything greater, let's say I had 4, well then then it was 4 was greater than 1, 2, 3, or greater than or equal to 4. So it printed the first, second, third, and fourth statements, but you really only wanted to print 1. If you do Magic 8 Ball, it doesn't give you 4 options, right? It's just one definitive answer. So if you did greater than, then you would have to say, okay, if it's greater than 8, print this. Else, if it's greater than 7, print this. Else, if it's greater than this, right? So you can do if else's would be one way of doing it. Or you can just use a double equal sign, right? That checks for equality. And if I got one of these 8 numbers, then we printed out one of our random 8 statements there. So again, if you gave it a shot, you got something close, I'm giving you credit for it. The idea was just that you worked on this over the break. That's how you get your hours for over a break here. If you want to give it another shot, you're welcome to do so. Don't feel like you have to get it to get 100% perfect, because we're always going to go over it immediately. Yes?
Well, I have brackets on every other line, and you don't have any brackets.
Oh, so remember we said, so you could have these, like the curly braces here, right? If you don't have them, then it's only going to include one line as part of your if statement here. So it's a good programming technique, but if you know there's only one statement below the if, then you don't need it, they're optional. Remember we first went on the if statements, we say if this, else this, and we didn't have it, but if you want to put multiple lines.
What are they there for?
So it kind of groups the code together. So let's say I wanted to print out yes, and I wanted to print out also if it was number 1, I wanted to say print out my random number as well. So let's say I had 2 lines here. Well, now I need them here. So if this is 1, it would do both of these lines. If it's not 1, it wouldn't do this. But if I did this, if I got rid of these lines, then only this line is part of my if statement, and this, I may as well indent it out here, because then it would always print out random number, because it's not part of my if statement anymore. So that's why we have is to kind of group what I want to go underneath my if condition. And usually we have more than one line. So yeah, here I don't have them because I knew I only had one line, but if you have them, that's actually not a bad programming technique to use. I was just keeping it shorter here. Good. Any others on this one? On the countdown, since we hadn't done for loops yet, a lot of you did, I saw some of you did for loops as well, which is great. Here, if I look at the countdown solution, so this was the original, right? Whoops, that wasn't it. What happened to the, is it here? Okay, here's the original. So what happened with countdown was, we asked you for a number, please enter a number, and I did that injured up parsing to make it a number. So num is my number. So we wanted to check to see if the number was greater than or equal to 1, but also less than 10. And if it is, then you wanted to loop all the way down to 0, blast off, and then go around the moon without landing on it. And then, otherwise, we're going to print, I'm sorry, Dave, I'm afraid I can't do that, which hopefully that doesn't happen to our astronauts out there. Take us home, sorry, folks, can't do that. Yeah, so we have this if statement here, and then notice I have a loop, and then, so that's what we want to do. So let's look at a solution here using a while loop. So I just put the code in amongst the comments here. So here's my, number, right, num. So first, check to see if it's greater than or equal to 1, but also less than or equal to 10. So I have my if statement. If num is greater than or equal to 1, and num is less than or equal to 10. So if it falls in that range, here's my curly brace because I'm going to have a lot of code in here, so I definitely need curly braces. So what do? I want to write a loop that prints a countdown from the number to 0. So here it is using a while loop. So while number is greater than or equal to 0, because I want it to print 0, I just print out the num, and this is my curly braces, and then say num minus minus, that counts it down. So if I put in an 8, it's going to print out 8, and then num is 7. Is 7 greater than 0? Yep, print out 7, it's now 6. 6 greater than 5, 4, 3, 2. 1 prints out 1, now it's 0. Is 0 greater than or equal to 0? Yes, so it prints out 0. I know they don't say 0 on the blast off normally, right? The 5, 4, 3, 2, 1 blast off. That's why I'm not an aeronautical engineer, I guess. But and then num minus minus, it's now negative 1, which is not greater than or equal to 0. So then it just comes down here and prints off blast off. But if it wasn't between 1 and 10, then it skips over all of this and goes to my else statement and prints out, I'm sorry, Dave, I'm afraid I can't do that. So that's what we have for the program there. Questions on this? Now we can also use a for loop to do this. So let me show you a for loop solution. Same exact if statement, if num is less than 1 and num is less than or equal to 10. If it is, well now instead of a while loop, I just did this. Notice it's the same three things. I needed that counter variable that now, before I just used num and I did num minus minus. But if I do a for loop, I have to have an initialization, a Boolean check, and an update. So here I had a variable I was equal to num, there's my initialization. While I is greater than or equal to 0, I minus minus, print out I. So it's not really, it doesn't buy you anything to do it either way. Same exact code, but in this case, I do that countdown and then I print blast off, else print, I'm sorry, I can't do that. So the only thing that changed is this code right here, just a different type of loop. And that was it from last week. So questions, comments, or anything else about last week's assignments or code or anything? Cool. Also, if you have any questions, any of the quiz questions, and I know it's with spring break and everything else, please try not to get too far behind. If something closes out, you want me to reopen it, just let me know. I do lock them out after like the next session after. So I think everyone got their Pig Latin and the, what was the other one, Pig Latin? The other one in. But then, so if you don't have this turned in yet, make sure you work on this as well too. Yes?
So I did have 2 quiz questions, but I can email them to you.
Sure. Yeah, because so if you want, and then if you got one question that's really, email it to me and I can pull them up in front of the whole class and go over those particular ones. I know it does, I think it scrambles them, so I don't, it can't be like question 3.
Okay.
So, but let me know, yeah, if you have any of those, even if it's from our previous quiz, you're like, oh, this one's been in the back of my head now for the past 2 weeks. Let me know, I'll be happy to go over that together, because that'd be a good review for everybody too. So if you have any that were that you were questioned about. All right, anything else here before we get moving into the new stuff? All right, so as I mentioned, this is the Unit 3, and we were talking about hardware networks, and then we'll get into object-oriented programming. We'll talk about classes, objects, and encapsulation. But we are going to start with networks here. And I will try to make this interesting. So I'm not sure why they include this, because a lot of times I guess people with certifications, they're responsible for making sure things are working around their school and all the Wi-Fi hotspots. I know we have county people to do that as well, but this is something that they feel is important for the computer science certification exam. Most people in computer science tend to be very software oriented. My degree is computer science. I never had to build a computer from scratch. That's usually computer engineering, differences there, or but we're going to talk about networks here. Oh, and speaking of, just look at my next slide, study.com. You all should now receive from Faith your study.com. So if you want to go back, it is different from CS Awesome because it is geared specifically towards getting you ready for the test. So that combined with CS Awesome, I think, is the best of both worlds. But you'll find that they're not exactly the same. So I try to put up what would be a good resource in study.com for this topic, and what would be a good resource in CS Awesome for the topic. All of the stuff that's non-Java, it will not be in CS Awesome. So for this right here, the best stuff to get more information than what I have for you in the slides, if you want to go through, Chapter 6, which is right in the study guided practice. And if you haven't logged into that study.com license yet, do that. It's really good. They have a lot of resources there. And if you're interested in getting ready for any other Florida certification test, you can do that while you have a license there. So that's what I'm just saying. So it's good.
Are you serious? We can use any, we can.
Oh, you can do any course in study.com right now until the license is done. I don't know how long the license is for.
Like 3 months.
Like 3 months,
Yeah,
yeah.
only just 3 months.
So.
Can you do that, study.com alliance and not just 1 and 2, like you're doing like that?
Yeah, so if you go back to the slides, you'll see it'll have the study.com resources and the CS Awesome resources in the other slides as well. And we just haven't had a chance to do that. So for this one, I actually pulled a couple study.com questions that we'll go over that are very similar to what we'll see on the FTCE test as well as we pull those through. So this one is the basics of network system technology. So here we go. We're going to talk all about networks and what they are and how they what they look like. So networks, computers are great. Networks are what allow our computers to talk to each other, right? Everything, these systems, or your phones, your tablets are great, but when they hook up to a network, when they hook up to the internet, when they communicate with other computers, that's when they become super powerful, because then we have all this knowledge at our fingertips. So there's a lot of different types of network architecture, how these networks are set up. Some people really get excited about this. I will try not to show my lack of excitement for it as we go through. But we have different types, some basic types of network architecture. These are changing all the time, right? Because we'll talk about like different transmission mediums, and I used to have cable, and now maybe you have fiber optic, and what's the difference between that, and what's wireless and wired, and all the different types of ways all of our computers are connected. The basic architectures that we'll talk about are, first of all, a peer-to-peer or a P2P network. It's where you have a group of computers together, whether it's wired or wireless. There's no real hierarchy, but they share information all around. A client-server network is more along the lines of kind of how a lot of cloud services are. We have a big server, a big computer that may, like where your Google Docs programs actually run, or things like that, and your Chromebook is a client. You're actually connecting to this, and you're running everything from somewhere else. You're just using your computer as a way to communicate with these other repositories of information. Maybe there's programs actually running out on that server that you're utilizing. And then in a mainframe system, a lot of times, and this is a little bit less common even in the business world, where you have these larger systems. And if you ever see like in a movie some of these big computer rooms and someone just plugs in a little keyboard and terminal to that large computer, it would be a mainframe there. And you have individual terminals to access that. But now, this is a little bit different because we have all of these individual devices all hooked together through all different kinds of networks and the interwebs and everything else that we have. Networks of different sizes. This is the first one, personal area network, is more of a more modern term that we have. It's the idea of organized around a single person within a single building. Maybe you have your tablet is hot-spotted to your phone, which is then connected to the internet, and maybe you have different Bluetooth connections. Your AirPods are connected to your phone, connected to your tablet, connected to maybe your PC, all the different devices within your use area. A local area network, or a LAN, that's the idea of a single network at a single site. That used to be the case here, like at all the schools, where I don't know if you've been here a while. You remember we didn't have OneDrive, we used to have like an H drive, and a lot of those used to be, that would be in a server, a big computer located like ours in our media center, and we would have, the students would have all their work they could access on an H drive, and anywhere in the school they could access that. That was a local area network. Then they moved those servers to the county, I think, for a while, and now it's just OneDrive. We don't even have those. You know, we're not responsible for all the backups of your work now. It's all stored with our contract with Microsoft, and they have their server farms somewhere in the world. Was that? The H drive is still there? Oh, I guess we have it, so somewhere.
It's there, but they limit who's allowed to.
Yeah, it's not. Those
You're not
students
allowed to
don't
make
use it.
changes to it.
Sure.
It's locked down.
If you have some old repositories there, but like students don't have it anymore. When they log in, they don't have. They used to have like a shared student drive as well. But so that's changed a little bit. A metropolitan area network is something across like a large city campus, right? If you're within that range, you're logged on to, like, anywhere on a college campus would be a good example of that.
Would that be similar to how Seminole County does, like, if I take this laptop
Yes.
here in any Seminole County school, it automatically connects? and-
Exactly, only, but yet you disconnect while you're traveling from one school to the
Yeah.
other, where most of the time when they look at a metropolitan area network, it's all connected in that area. So that would be kind of like different hotspots, so that's a variation of it, but same idea. But the idea of that metropolitan area network tends to be more of a confined in a larger space. But yes, like, so if you're here, you log on, and you don't teach here, but you can connect to, obviously, to the Seminole County network because of all of our access here. The wide area network, well, that's what we talk about. We talk about the internet, satellite, communications, colleges, universities, military has their own network. It's not just the internet as we know it. There's lots of other wide area networks that are out there that are restricted, that we don't have access to. But it can be over an entire country, the entire world. The internet's one of the best known examples of this. And then we talk about wireless networks. Any of these can be wireless networks. So it's not, a wireless network is not a type of network, it's the medium over which this network is built. You could have a wireless local network, you could have a wired local area network, right? Any of these could be wired or wireless as well. Some terminology that we're going to talk about in these different, when we talk about the architecture, some things that are here, you'll see how these can come up in some of the questions. This is just vocabulary, and do your best to become familiar with it. So the repeater, some of you may have this, it takes the signal and retransmits it. So like if you may have like a wireless network in your house, but like you can't get good signal in like across in the other corner of the house, so you put like a repeater or something else that allows your signal to be boosted. You know, that's it. So it's transmitted. So repeaters can increase that signal over distances. We would use that with wire and with wireless networks as well to boost the signal. A hub allows multiple devices to be connected to the network using cables. I used to have a hub in here because I only have so many ports, so I'd have everything there. The difference between a hub and a router here is that when a hub receives data at one of its ports, it just distributes it everywhere and hopes it gets out to the right computer that's connected. A router actually is a little bit smarter about where that information goes. Bridges divide the network up into different segments to manage traffic. If you have like a busy office building, lots of traffic, internet flow, you don't want the design team on one floor interfering with the product development on the other floor. You might route where their internet traffic goes so one group doesn't slow the other down. As it becomes more complex, the network, it helps to make sure your network speed doesn't drop in certain areas. Routers connects different devices, different networks, and it sorts that data and distributes to the correct destination. That's a little bit different than a hub, where a hub just kind of says, hey, I got all this stuff, here's a bunch of information, I hope the right computer gets it, whereas a router says, oh, this information is going here, this is going to this, I got the internet coming in here, and this PC made a request for this web page, and you're printing to this printer, which is on the network over here, and the router helps distribute that. A lot of people have a router at their home personal network to help distribute everyone on their home wireless network or wired network as well. A gateway allows two different networks that maybe have two different protocols, which is the language of the networks, to kind of connect the two so that it connects two totally different networks together. It says you can think of a gateway as a router that includes protocol translators. That's how one network may speak and how another network may speak, and it allows those two networks to connect together. The modem is used to, as it says here, modulate and demodulate. That's where the word modem comes from. It takes information and decodes it and transmits it back to digital. So like as you're sending a signal, it can then, it can take information from the internet and then put it into a type of signal that your computer can understand. If you all remember back in the day, us older folks, like your telephone modems, where you turn it on and it was just trying to get all that. And it was making that connection to the computer. You're waiting. Oh, they're connected. I can send 4 letters now, and then I get, in about 4 hours, I might have a song. But that was, so that translation. The network interface card is what every computer has so that you can connect to a network. So if you want to have a network connection, you have to have a network card or a network card-like device in your phone, your tablet, your PC, your computer, whatever that is, so that you can connect to the network. And now in today's society with the Internet of Things, where it's not just computers, traditional computers on your network, you may have your Nest thermostat, or your Ring doorbell, or your smart refrigerator, or your smart toaster, or coffee maker. Everything's hooked up to the network, right? They all have network
Your washing
interface
machine.
cards, washing machine, anything else, you know. Yeah, there's everything get hooked up to your network now, and so they all can interface to there. The routers help that communication. Okay, so that's some just basic different tools of networks. Let's talk about what we call network topology, which is a fancy word for how is it put together? What's the layout of the network? And that varies based on what the site needs, what the site is laid out at geographically, both in whether buildings in an office or rooms, offices in an office building. And a lot of times networks are combinations of these, and we'll see some combinations of the different networks. Point to point is real easy. I've got a computer and maybe another computer or a printer, like a computer and a printer, and my computer's hooked up to my printer. I've got either a wire or a wireless, and I can connect to there, and it talks to each other. I don't need a router or modem or anything else. I just say, I plug in my printer and I connect to it, and that's a network, right? That's one computer talking to another device. It's faster, very reliable. How many times have you had your wireless printer? It won't print, you reset the computer, printer doesn't work, but then if you have that printer hooked right up into your computer, sometimes it prints right away. So the disadvantage, you can only use it in small areas, right, when you're connecting directly there. You hook your tablet up to your computer and download pictures off of it, things like that. That's a point-to-point. Then we have a bus, where we have a main cable, which all the different computers are connected. So a lot of local area wired networks, like here in the school, if we connect, there's data ports in the wall. These are all wireless now. Believe it or not, I just got these last year. So last year's class, we actually had all those yellow cable wires sticking out of the wall here because it's 2025. But all of that, and they're connected, and then they would connect to the network, they would connect to a router, connect to the internet, and things like this.
Did you notice that it runs faster when the yellow cable is on?
Oh sure, yeah, that's my phone line. Let's hear, but yeah, so of course it's faster, and the wired, yes, is definitely, we talk about wired. It's faster, more reliable because there's a direct connection, 100%. The advantage of this is that you can pull computers on and off that network really fast, right? I'm still recording good. I can unplug a computer and plug in a computer, and it's real easy to replace devices. Disadvantage, that if something happens, like if all these computers here were hooked up to whatever they're wired to, that gets cut, all of these go down, right? So it's just because it's one big main cable. So how do we avoid that? Well, there's other topologies, one called the star. So maybe I have, and a lot of computers will have this within other networks, a hub where I only have one plug, but I've got 6 computers. So what do? Well, it's kind of like an extension cord, right? Or there's like one of the power strips, right? But it's a network version of that. So I can plug in a whole bunch of computers into this hub, and then maybe I could hook up to a printer, or maybe a connection to the internet, or to the rest of the network. Now the problem is, it's very popular because it's very cheap to do. You just plug all these computers in, but if the hub fails, everyone goes down because they're not all wired in directly. A ring is very similar because now it's easy to install and manage, and if the wire breaks somewhere, you can probably get around going the other direction in the ring. However, it's a little more cumbersome. If a computer fails and it fails to help the signal go, then that can be a problem as well. That's not really a common type of topology, but guess what a ring looks like? It looks like a circle. Guess what the star looked like? It looks like a star. So you can kind of get the idea of keeping those straight as to what different topologies there are. Then there's this mesh. And what does a mesh look like? It looks like a mesh, not a mess, but a mesh, like a netting thing. Now this is actually great because the advantage of this, all the computers are directly connected to everybody else. So if this one wire goes down or this computer goes down, that's okay. All these can still talk to each other. So it's very reliable, It's also security is high because they all travel along dedicated connections. I can say that maybe this might be a secure line and this is a secure line. I have some other different firewall technology between these two computers. The problem with this is disadvantage is real expensive. I mean, just the wiring alone, right? And then if something happens, troubleshooting this can be a little problematic because there's so many different pieces involved in this as well. So that's our topology, the mesh topology. Then you have something like a tree. If you think about a tree, it's a bus with our stars. Remember the stars are the hubs? So this is like multiple hubs connected to a bus or a main cable. So now we get what we call a tree. So it's, and again, so now if you want to maybe take this offline or take this offline, there's a lot of flexibility for expanding the network now because you can easily get large groups of computers onto the tree or onto this network as well. Each hub is like a root of each different tree of devices. Again, this would be so we're talking about combinations of different topologies. And then the hybrid one is just a fancy word for saying lots of combinations of everything. Here I might have a bus network which is connected to a star network, which is connected to a ring network. However, the IT department of a particular facility feels it is best way to manage the network properties for their location. And then there's a lot of, like I said, I kind of gave you the brief advantages, disadvantages. There's a whole lot of things that come into consideration there, right? We talk about speed of the networks and everything else, and costs, startup costs of putting things together, and reliability and things like that. But those are just kind of the different organizations of the networks that you can have that you might be asked about as well too. So we'll see some examples, some questions there. In addition to that, this is one thing that talks about the open systems interconnection, the OSI model. This is the idea of if I have a device and I want to get down to putting information out on that network, it goes on the network and then it goes from the network back up to the device. What are the steps that it goes through? And there's this idea of called, and there's a few different models. This is the most common one, this open systems interconnection. It's how the communication protocols or the languages work with each other. And what happens here is this top application, what we call the top level is called the application layer. This is where your software is, it's what interfaces that you use on a computer, and then it goes through all these different layers until it goes down to what we call the physical layer. So we're sending bits of data through the wires, through the channels, and then when it gets to the other destination, it goes through all these layers back up to the application that the person who's receiving that information sees. Why do we have all these layers? Well, there's one layer that's in charge of data conversion. There's one layer just in charge of breaking it up into packets to get ready to travel. There's one layer that controls the flow and looks for errors. And the reason we have all these different layers, and this is kind of a universal model, is because as network technology increases or improves, you can replace one layer without replacing an entire network. So if you want to update, hey, instead of going through like the physical layer, instead of going through cable like Spectrum, which is coaxial cable, we're going to replace that with fiber optic cable, which is higher speed, but I don't have to change, I don't have to re-download Microsoft Word in order for that to work now, because that's separate. So all of these layers are separate. I don't need a new, well, you may need a new cable modem because that works regularly with that, but I don't need a new router just because I went from Spectrum to AT&T wireless or AT&T fiber optic. I can still use my router because I have a different modem. So there's different layers, and as the technology improves, I can just replace different layers and not have to, but they all work within the same accepted model. These are standards that we have. So that's what the OSI model is. All right. That being said, let's look at some questions. Here are some sample FTCE questions that you would see. This is right off their site, based on networks. The first one says, which of the following devices would be most appropriate for connecting a local area network using one protocol with a wide area network using a different protocol? Now, one group says, oh, wait, a bridge might be good, but you don't actually, that's part of the network design itself. But what if I have a local area network and I want to connect it to the internet? What would connect my local area network to the internet? Or what do you use at home to connect your, use a router? So the answer is C. Which of the following layers of the open systems interconnection model, because we just went over that, is the wireless technology implemented? Now you say wireless, that's not the application level, right? My Angry Birds app doesn't care if I'm wired or wireless, right? So it's not there, it's not at the application level.
Physical.
It is down at the physical level. Again, if you look back here, let me go back, physical layer. It's through a physical channel or wireless. So the transmission medium, that's the physical level. So where is the actual wireless technology implemented? Down at the physical level. And we have the different levels in between to translate that back up to your computer. That's the type of questions you would imagine seeing about networks on here. Here are a couple of, and this is the last slide, couple of study.com questions that I thought were really good because this is also very related to the types of questions you would see. The first one, what is one characteristic of a mesh network topology as compared to a bus, star, or ring topology?
Most expensive to configure and troubleshoot.
Most expensive? Yeah? Yeah, so remember the mesh is not easy to install and manage. It's not the simplest, and it's certainly not low. It's because there's so many wires and pieces and parts, the mesh should be the most expensive. Very typical type of question. Which of these describes a WAN? Remember we had a PAN, a MAN, a LAN, a WAN. That's a wide area network, right? So what do you think?
The first one.
Computer network that occupies very large areas such as country or the entire world, a WAN. So we have WAN, MAN, LAN, PAN, MAN. I think I got all those. So
I think of world and WAN.
Yeah.
W.
Yeah.
Makes it
Wide area
easier
network.
to remember.
Hey, that was networks.